Hello, we are Team BBQFG and this is our app Secura. I am Russell Zhu and I am the project manager. I make sure that the deadlines are met and I give constructive feedback to my teammates regarding their work.
I'm Zach Canode and I'm the graphic designer for this project. I mostly use ideas from Russell to create a good-looking and consumer-friendly app.
I am Sagar Patel. On this app, I mostly worked on the front end, so I took what our designer Zach created and turned it into something that the user can interact with. I also worked on a portion of the backend programming.
Hey, what's up? My name is Andrew Reniger, and I did the backend coding, including authentication, data storage, computing, and security.
In 2017, Regan Tokes, an OSU student, was tragically taken away from us, and her body was found at Scioto Grove Metro Park, about 10 minutes away from our school. License plate readers on top of a police car alerted them of Regan's car, and there, police found crucial DNA evidence that would put the killer behind bars. In our community, justice is not correctly served as many criminals are not caught because of the lack of video evidence. The integration of our hardware and app will help police gain a clear understanding of the path of subjects, as well as help private corporations ensure the safety of their property. We also implement proactive and retroactive aspects to our app for the safety of the community. We want to increase the quantity and quality of license plate readers by providing law enforcement and private companies with cost-effective cameras and innovative software that protects the safety of our community. We plan on testing our app and hardware around Grove City and Columbus before expanding to other cities.
For the early design, I worked inside of Adobe XD to attempt to create the most user-friendly design possible. Russell and I designed our layout on paper first and moved it into XD. For logos and images, I designed them inside of Gravit and then moved them into Adobe XD.
For the front end, I use XML mainly because of its syntax. It's very easy to read and understand. I also had previously worked with XML, so it was quite easy to relearn it and use it for the app.
We chose to use Firebase for its NoSQL database, integrated security, and low cost. For the processing of images, we chose to use Python with C++ bindings, which is all run on an EC2 instance hosted on AWS.
Our current prototype for the physical device uses a Raspberry Pi with a camera and a cellular device for connectivity. As soon as our device turns on, it begins taking pictures. It then uploads them to our database. If offline, our device can take and store pictures for up to 3 days at a time, at a rate of 1 picture a second. When a picture is uploaded, our code analyzes the picture and saves the data it finds. The picture is then archived. We are currently using an EC2 instance on AWS to run our code, but it could be run anywhere.
We are currently running our app in an emulator in Android Studio. The app starts with a quick splash art transitioning into the login screen. Every company will have a uniquely generated company code that changes the functionality of our app.
The login page animation was actually quite simple to make. The XML consists of 3 tags, 2 relative layouts, and an image view. The background of the login page was made in Adobe XD by cropping different shapes, so the background is just a simple image view. As for the relative layouts, the first one is for user input. It also includes our logo. The second relative layout is for the sign up and forgot password buttons. Moving on to Java, I set each tag I mentioned earlier in the XML equal to its own variable. Then I loaded the animation fade into a variable for easy access. I was able to get the background image view moving by animate.translationY. This translated the image 1400 pixels from the top of the screen in 800 milliseconds, after a delay of 300 milliseconds. For the 2 relative layouts, I just called the start animation function and passed in the fade and animation variable that was set up earlier. The XML animation file for fading in was also quite simple. It was only a single alpha tag with from alpha value of 0, meaning that it was fully transparent, to an alpha value of 1, which meant that it was fully opaque. All this happened in 4 seconds.
Once the login information is correctly entered and verified by the database, the user is brought to the main screen with a welcome page. Our app is currently set for law enforcement, but this can be changed based on the unique company codes. On the top left is a hamburger button that displays a profile image and the name of the user. Below the profile are 4 unique functions available for the user. Clicking the search function brings the user to a screen with 3 methods of searching: by color, plate number, and location. For this demo, we have preset values for color, but the final app will allow users to search based on different criteria. The search provides the user with scrollable results that are easy to view. In the license plate tab, the app restricts the user to a fixed number of license plate characters that the user can select for better search results. Once the characters are selected, the user can no longer add any more characters than the number selected. For example, Once we select 3, we cannot enter more than 3 characters. Clicking on the search result will bring the user to a detailed screen with the most recently captured image of the license plate and different information regarding the make, model, if it was attainable from the plate, i.e. from law enforcement, and the map below shows the last seen location of the plate on one of our cameras. The location tab allows users to search for a specific camera in the proximity with a certain date and time window, and our app shows all of the plates detected during that time frame. The search option is related to the retroactive function for when evidence is gathered after a certain event. The notifications and proximity scan allows us to proactively manage the traffic reported by the cameras and mark any unapproved vehicles detected by our camera. The user can input information about the car and the reason the plate is not allowed. This function is mainly for business owners and private corporations wanting to manage the traffic that enters their property and alert security personnel with our real-time notification about unapproved plates. In this example, a car has been detected with plate number DEF1234 on camera 1. Security is now alerted of this issue and can respond to people with a record of misbehaving on the user's property. Unlike current red light cameras, our cameras can be placed at any intersection or exterior of our structure. Our app is innovative because it will track the colors of vehicles and provide users with an estimated path of a vehicle based on a network of cameras. We have also taken into account the possibility of network failure and have taken steps to ensure that data is stored at the current location for up to 3 days. We anticipate problems with the community and American Civil Liberties Union, so we plan to follow the same privacy policy as law enforcement and keep video recordings for up to 90 days. Our product will work best with private corporations as this avoids these issues.
For this project, community impact was one of the biggest points for us. Our current prototype with a Raspberry Pi, camera, and various accessories is around $70 to $100. An increase in security for the general public and private businesses was a massive concern for us, as our cameras are more versatile and cost-effective than current cameras used today. It allows for a safer community. Since current cameras can cost thousands of dollars, our camera for only $70 to $100 is a massive decrease on price, making a huge difference in cost for both the police and private businesses, allowing for a tax break for the community, as police no longer have to spend tens of thousands of dollars on cameras. Also, since our cameras are so small and versatile, it allows them to be placed and configured to almost any space. Increasing the amount of cameras that a location can have at one time allows for a more secured community. This also allows the police to be able to track someone better if they have a warrant for their arrest, decreasing the number of active cases.
Secura is a cost-effective camera and security app that focuses on displaying information in a user-friendly fashion, all compacted into a mobile app. We finished coding the software for our cameras, and we plan on getting a better prototype as well as getting user feedback for our app. Thank you so much for your time. Be sure to leave any questions in the comment section, and we will respond as soon as possible. Please stay safe and exercise good hygiene. Thank you.